Hello, all. Welcome back to another session. So, in this session, let's focus on understanding about two important topics. Let me share my screen. Let me share my screen. Yeah. So, in the previous session that we have did this. So, let me have a thing like this, and I'll say in the previous session we have understood about one very important thing, which is known as objects, how to work with the objects, how to create objects, how to manipulate the objects, how to change the data inside the objects. All these things we have actually understood in the previous session. Now in this session, let's focus on today's session. Let's focus on one basic fundamental thing which actually helps us to do a lot of things, which is something about understanding object reference, um, and object cloning and garbage collections. So this is the agenda of the today's session. So we'll be understanding about object reference, object cloning, garbage collections all together. So how does garbage collection actually works inside the JavaScript? That's a very interesting topic to learn about. So without any ado, let's go ahead and understand these things. So let me create this one thing, a new file. I'll say objref.js. Objref.js. So let's close all of it. Let me open my terminal and yeah, let's go ahead and let's try to learn about this given particular thing. Also, object references. I'll say object references and copying. So I need to clearly mention this one very important thing, which is nothing but one of the fundamental one of the fundamental differences of object versus primitive data types, or I can say primitives, is that objects are stored and copied by reference. What is meant by this given particular thing now is that by reference. By reference. Whereas primitive values like strings, let's say we have this strings, numbers, big int, boolean, all these kind of things. All primitive data types. The seven primitive data types are always sorry, are always copied as a whole value. As a whole value. So that's easy to understand if we try to understand how exactly is actually happening with this respect to things. So what exactly happens when we copy a value? Let's start with the example of primitive. If someone says let msg is equal to actually hello. Now how does this thing actually stores? Let me open this one thing. Let me open this Scalidra. Right. So here whenever we have written the code in this format, let msg is equal to something known as hi. Now, how does this given particular storage actually happens here? Because we have a primitive data type which is string and we are trying to store it inside a single variable. So in memory, we'll be having a small box like this, which is actually named as MSG. MSG, a variable MSG. It has its memory space. It has its memory space altogether. Assume that this have this respective thing known as a memory space. So this entire orange thing that you are actually saying is memory space allocated by this given particular JavaScript interpreter for this variable known as MSG. Now what exactly happens with this respective thing is so whatever thing that you have written this hi will be stored inside it. So whenever you write the code like this, there is this kind of a thing actually happens. So this entire code, if you want to understand this entire thing in a graphical representation, this would look like this. So this is how this entire thing would look. So we'll be having a memory location like this orange box created by the JavaScript interpreter, and this entire content will be stored inside of it. This is how any primitive data type will actually be stored. For example, if we have something like let age is equal to 25, for example, then let me do this thing. We have a location, a memory location like age, and this 25 is actually being stored here. Is actually being stored like this. So this 25, where age, for age, there is this given particular variable, a memory storage will be created, and in that memory storage, this data will be stored. This is how this entire thing of, wait a minute. This is how this entire thing of variable storage for primitive data type actually happens. But coming back to this given particular thing, let me go ahead. Let me go to this thing. Yeah. But whenever we say um, this doesn't apply, whatever I have told, this doesn't apply for object storage. For object storage. Because how does this object will be stored inside a variable? Let's say if I say let user is equal to name to be Akhil, if age to be 25. So whenever I try to create this entire object using object literals, which is nothing but the flower brackets, and this if I want to store inside a variable, this doesn't follow the rules that we follow here. Whenever we have this a simple primitive we want to store inside a variable, we just keep that entire data inside that memory allocation allocated for MSG variable. But here is not the case. Here that's not at all the case. Right? Here that's not at all the case. No, that not at all the case, because you need to understand that a variable assigned to an object stores not the object itself, not the object itself, but its address in memory. In other words, I can call it as a reference, a reference to it. This is how this entire thing example. For example, here we have taken this example like this. Let me copy it. Let me go back to this escalator and let me explain it. So we have this respective data known as a variable has been created. Now, whenever we have this variable created, the JavaScript interpreter, what it does is it creates some kind of a memory location. It creates its kind of a memory location altogether. So this is nothing but our variable, user variable. Now, instead of this entire content, instead of this entire content is being stored here, is being stored inside this memory location. Let me grab this thing. Instead of storing this entire object into this direct users variable, no, users variable altogether, here it stores a different thing which is known as reference, which is nothing but this entire object literal, this entire object literal will be stored inside a different memory location. This would be some different memory location, something like 2003. Let's say this memory location where this memory location is called as 2003. Then this 2003 will be stored here in a user, in a variable user, in a user variable. So if you can clearly observe, this user variable is storing the memory address of the object. So in general, objects will be created at a separate memory level, at a separate memory, or in a separate memory location altogether, to be more precise, then whatever memory address they are stored in, that memory address will be stored inside these respective variables, inside these respective variables. So here this is what meant by, now here your user variable is storing the memory address of where the object exactly present. This is what meant by reference. This is what meant by reference. Is exactly what it is meant by reference. So here, whenever you are creating working with an object, the objects will not be stored directly inside the variables, but object will be stored in a separate memory location where for that memory location they will be having some memory address like number. That number will be stored inside our user memory, user allocated memory, right? So this is how this entire thing actually work. Oh, sorry, some screen change had happened, but fine, right? So this is what meant by storing through user reference. This is what actually it looks like, right? So here the address of this given particular object is being stored inside a respective variable. Now, when we perform actions on this given particular object, which is stored in a different location altogether. For example, let me go to the code. So here we have created object. We have now understood how the object has been created. Now, whenever we do something um, like this console.log user.name. So the JavaScript engine looks at what at that given particular address is present, which is nothing but for this given particular user object. It JavaScript engine will check what is the address that is present here. Once the address is present here, it goes to this respective object. Then it tries to access this name property or name key altogether. So this is how this entire thing actually works. It's like the reference thing. It's completely acted as reference things. You might be asking why this kind of a easy way of implementation where storing this entire data instead of the variable memory location is simple, but why we want to complicate the things with references altogether. That comes to this given particular point. Why JavaScript creators have chosen this way instead of storing this entire object inside the variable. For that, let me answer that question. So we can clearly say that when an object or when an object variable is copied, for example, copied, the reference is copied, but the object itself is not duplicated. For example, I'll say we have this user as name Akhil. I'll say let admin is actually equal to known as user. So here, copy the reference actually happens. To be more precise, we'll be having sorry, we'll be having another new memory location allocated for variable known as admin. Now this admin, so let me write it like this admin, where if you can clearly observe in the code, we have written as let admin is actually equal to user. So whatever details that are present inside the user should be stored inside this given particular memory location known as admin. So this 2003 will be stored here. This 2003 memory address of this object will be stored here. Then also we'll be having the same thing. We'll be having the sorry. We'll be having the same thing. This is the reference to the same object. Hmm. To the same object. To the same object. So why we are following this given particular thing is instead, for example, if you have this given particular thing, you can save memory in this given particular case because whenever you are creating a new variable, you are not creating this entire copy of thing and storing it here. Let me explain it. Let me be very clear. For example, here let message is equal to hi. At some point of time, I'll also say let uh, or I'll say let phrase is equal to hi. This phrase is equal to high. Now, how does this given particular? Let me say it. Let me have identical things. Right, phrase is actually equal to high. Now, if you can clearly observe, we have two different variables, but the data they are storing would be same. Their data we are storing would be same. But here also, what exactly happens? Here, the exact simple thing actually happens. We have this new variable known as phrase, and whatever thing that we have, this will be stored here. I mean, yeah. So here, the data that is being stored inside both the variables is same. But if you can clearly remember, here we are wasting our memory. Why? Because the data that is stored inside phrase variable, the data that is stored inside message variable are same. But we are having two different copies or two copies of the same data in different variables. The variable name, MSG and phrase are actually different. But the data that is present inside them is actually the same. So this is the disadvantage of this given particular primitive data type. But if I try to apply the same case, for example, in the same case, if I try to apply here, I'm just storing the reference numbers. I'm storing object at one single time and I'm storing its reference numbers. Due to this, what happens is like, let's say we have occupied or we have used around 2 KB of space. Wait a minute. We have used 2 KB of space to store this given particular object in memory. Now, instead of creating duplicates, sorry, creating duplicates and storing, here again, I need to copy waste 2 KB. Similarly, I have to keep here and I have to do this. So total around 6 KB of same data, but stored in different variables, user and admin. I'm actually creating around 6 KB of wastage of memory. So instead of that, what if, wait a minute. Yeah. What if we create this object at a one single place in the memory? Let it occupy 2 KB, 4 KB, any such kind of a space is fine. But whenever we want to store this object inside this respect to different variables, we don't store the object itself, but we store the memory addresses. So they refer to these things. So this storing number, storing a primitive, see, similarly here it is nothing but storing a memory address. Storing a memory address will take way more less memory compared to storing an object itself altogether. So user now will be storing a data around of some 0.1 KB. Where is 2 KB and where is 0.1 KB? The same thing happens with, sorry, same thing happens in this same case, 0.1 KB. Admin will be storing 0.1 KB. User variable is storing 0.1 KB in their memory locations altogether. This is the reason why people actually went for this given particular thing to save the memory. To save the memory. Because at a complex given particular example, if we don't control the memory, then it entire program will spills out. That's why people went for this reference method instead of storing respective data like this into each and every variable. We are just having different copies of same data in different variables. Of same data in different variables. This is just a waste of thing. Instead of that, create a data only for objects, create a data or create an object at a given point in memory, and then share its memory address to different variables so that they can store the memory address. They can store the memory addresses altogether. So this is how we have this thing known as a concept of references. The concept of references. Now, even though if I try to do this thing, admin dot name, if I try to admin dot name, what exactly happens? I can also get the result as, I'll say Akhil. I have this thing known as an Akhil, right? So this is how this entire thing is actually being worked. This is how this entire thing is actually being worked. Now that's how this entire reference thing has been came into the picture. Um, Give me a minute. Yeah. Let's come back to this respective session. Now let's try to understand this one very important thing. I'll say comparisons by reference. Comparisons by reference. So what does this given particular means? Let's say, for example, two objects are equal only if they are same object. If they are same object, for example, I'll say let A is equal to an empty object. Okay, A dot not A dot. Let B is equal to A. Let B is equal to A. So here what exactly happens? Copy the reference. The same thing, the example that I have actually previously told in Excalibur, the same thing is exactly happening here also. So this object will be stored in a different memory location, and that memory location will be stored inside A and inside B. Now, when I do this thing, console.log A double equals to B, and if I do console.log A triple equals to B, what will be the result? Sorry, I'll say node objref.js. Right. You'll see both these values are actually true. Both these values are actually true. So two objects are equal only if they are same object. You can clearly observe here object A and object B both are actually equal. Even for normal equality check and for strict equality check, we got the values as true. Because on the left hand side, on the right hand side, A and B are now referring to the same object. A same object. That's what meant by this thing. That's what meant by this given particular thing. And if you have this case, let me explain it. And here, two independent objects are not equal. Two independent objects are not equal, even though they look same or they look alike, to be more precise. For example, if I say let C is equal to an empty object, oh, let D is equal to empty object. Now, if I do the same thing, C is actually equal to D or not. Let's do the strict equality check. C triple equals to D or not. So in this case, you can clearly see this is false. The output, sorry, is false. The output here is also false. This is false. This is false. There, fine. Because if you can clearly observe, C is an empty object, D is an empty object. But one very important thing is C stores this is altogether different object, empty object created in separate memory location, and this empty object is created in separate memory location. So C and D have good number of chances that they both store different memory locations altogether. So these are here two independent objects are created. Two independent objects are created. And another important thing I just want to mention is when you are, sorry, let me mention for comparisons like obj1 greater than obj2 or any comparison like obj double equals to 5. Whenever you're comparing an object between like this or whenever you're comparing object with a primitive data type, here objects are converted to primitives. We'll study how about this given particular thing, why these comparisons are actually needed very rarely, but these are very important mistakes that we need to understand. And another thing I just want to mention is const objects uh, can be modified. Const objects can be modified. An important side effect, this is a very important side effect of storing objects as references is that an object declared as const can be modified. Object declared as const can be modified. For example, I'll say const user is equal to name Akhil. Okay, let me go about this. Let me clear it off. Let let me get it off. Right. Now I can say user dot name to be something like Nathan. And I can use console dot log user dot name. And if I write the code, you'll see output is Nathan, not Akhil. Whenever here the thing is whenever we are having const variable, we cannot change the data. But whenever you are creating a object with a const, you cannot change this entire object, but you can actually change the properties that are present inside it. If I want to add something like user dot age is equal to 25, so here I am trying to add a new property age with the value of 25 into user object. I can do this thing because as we are storing objects in the format of references, we cannot change this entire object. I cannot say user is equal to something like a different object altogether. This cannot be changed. This entire object, I'm talking about this entire object. If I try to remove this given particular thing, I'll say user is equal to some 25. This is not possible. This gives me an error. If I want to change it to different thing like this, age 25 or experience, experience 25 years. Whenever I want to change this complete object, this if I try to change this complete object which is under const, here then I'll get error. But if I want to modify, if I want to modify like this, if I want to modify like this, then I'll not get any kind of an error. Then I'll not get any kind of an error. Sorry. Right. Then I'll not get any kind of an error. This is the one thing that we need to understand. Now coming back to this one fundamental thing. Yeah. So let me go to this thing. Let's try to understand this thing. It's a very interesting example. So let's try to understand cloning, merging, G-I-N-G, merging, and let's also try to understand object dot assign. So one very important thing we need to understand is object, or you can say copying an object variable creates one more reference to same object, as we have seen in this example specifically. Yes, whenever I did this one single thing, whenever I did this one single thing, we are creating a different reference. We are creating a different reference to the same object. But the question is, let me go to it. But what if we need to duplicate an object? What if we need to create a duplicate of an object? So what we can do is we can create a new object and replicate the structure of existing one by like iterating over its properties and copying them on primitive level. For example, to understand this, let's say we have this given particular user. Let me comment it. Let me take a fresh example. I'll say let user is equal to someone like name Nathan, and I'll say age 25. Age 25. Now let's say let clone is equal to this. Now let's copy all user properties. Let's copy all user properties. Give me a minute. Let's copy all user properties into it. So whatever properties that are present here, I need to copy into this given particular empty object clone. So I'll say for let key, sorry, let key in user. I'll say um clone of key is equal to key. Clone of key is equal to of key. I'll say of key. User of key. Now if I console.log clone this one thing, what exactly I'm doing? I am running a loop, a for loop on this given particular object, on this given particular object. So this key variable will go to first this property and go to second this property, second this property. So what I'm doing here, I'm technically running this for loop on two objects, specifically, to be more precise, currently I'm running this loop on one log. It might look like that this for loop is actually being run for two objects, but it's not the case. I'm running only for loop for this given particular object known as user, because I have written this respective thing known as an for loop for this respective uh, object named as user. Now I'll say, right, now I can clearly see whatever data that is present inside user object. Now I have the same thing inside my clone using this given particular thing. Even I can clearly see clone dot name, I'll get the value as Nitin. Clone dot age, I'll get the value of 25. If I say user dot name, I'll get the answer as Nitin. User dot age, I'll get the answer as 25. So this is what meant by cloning actually happens. But this is very old method to do it. Instead, I'll take a sorry. Instead, I'll take this one. Let me keep it like this. Yeah. Instead, let me take a new way of cloning the objects, cloning one object into another object. So for that, we have this given particular thing known as an object dot assign. Object dot assign. So the object dot assign would look like this, where we have to mention the destination, like to which empty object that we need to copy, and we need to add sources. We can add multiple sources. So for this, I can simply mention it as let's say let user is equal to something known as name, like Nathan. Now what we can do is, let's say we have this option known as to edit preferences, whether we want to give a person viewer uh, viewer security or not security permissions, viewer permission, or to edit a file. For example, let's say there is an example of Google Doc. For a Google given particular doc, we can add the respective user to have whether he can have a view permission, or whether he can edit the permission, or whether he can both edit and view the permission. We have this given particular kind of permissions. So let me take this one single example where I have two permissions. I'll say let permission one, where I'll simply mention it as can view is true. I have another permission. I'll simply say can edit a file. So we have two permissions. We have simply two permissions. Now, if a given particular user is eligible, now I want to add both the permissions to the respective user named as Nitin. So what I'll be doing is I'll simply say object dot assign, and I'll mention user, comma, because first things first, I need to mention destination. So here this user with the name property Nitin, specifically with the name property where value is Nitin, should get both the permissions, where it should have, or this object should be having both the resources. Yes. This user object should have can view value, can view property, and can edit property inside of it. That's why I have added this given particular thing. Now if you run the code, console.log user, then you'll see this code going in this pattern. You can see a user named Nitin has the permission to view and has the permission to edit. right? This is how this entire thing actually works. For example, we can, instead of writing like this, if I have done this thing, object dot assign, not adding, assign, if I say user comma name to be something like Akhil, like in this example, in the below example, we have or instead of we have user object has already has name or has property name, like user already has this property name with some value, but here we override it, or here object dot assign will override it. Once this actually happens, it will not, name here will not be Nitin, it will be something known as Akhil. Even if you want me to do it, I'll let me copy it. User dot or user, let's keep it right. If you can clearly see now, once we have this given particular name property that is already available inside this respective user, it is actually being overridden. Initially it is Nitin, now after overriding it is like this, it is like this. So this is how this entire thing actually works. So coming back to this cloning example, coming back to this cloning example, we can simply do this thing. I'll say let clone is equal to object dot assign, where I have this my destination folder or destination thing where I want to copy is empty object. As we have did here, we have created an empty object and we have ran for loop and we have copied each and every element into this clone object. But here we'll simply say, we'll mention the destination where we want to copy, and we mention the source. The source is this. The source is this. From this user, copy all the things into an empty object, and that need to be stored inside this variable known as clone. Sorry. If I say console.log clone, you can clearly see whatever data that is present here, this entire thing is also present here. Entire thing is also present here. So here we are creating a duplicate. Here we are actually creating a duplicate. Here we are making the copies of these respective properties altogether. Respective properties altogether. And there is this interesting thing. What is this? Let me give me a minute. Yes. We have this thing known as a nested cloning. Nested cloning. So unlike here, we have a simple object with one single property. Let's try to complicate this thing. I'll say let user, okay, let's rename it. Let user is equal to this thing where name is equal to something like Nathan. And let's say we have this mm, um, size. Let's try to have something like height to be some 50, width to be something 90. Sorry, it's still comma. So now one thing where if you can clearly observe, we have an object known as user, where inside that we have another object known as size. We have another object known as size. Now whenever we have this given particular nested objects, where an object present inside an object, this is an object which is present inside an object. Now whenever if I want to access width, I have to do this thing console.log. I'll say user. I mean, first I'll say like this. If I want to access this given particular property known as width, I'll see this property is present in which object. It is present in size. Now this size is also a property which is present in user object. So I'll say user dot. Then you'll get these things, name or size. And if you say size dot, height or width. So this is what meant by nested. From user you access size, from size you access width. This is how we can access width property. Yeah, You can check it out. Okay, let me say it. Clone. Right. Like in case we have successfully in this given particular thing, we have successfully achieved this or tried to access this given particular width value. We have tried to do that given particular thing. Now, um, when you want to clone this kind of a nested things, it's not enough. You just clone only the users part, only this users.sizes part. It's altogether different because if you can clearly observe, we have an object user. To clone that, we have to use object.assign. But another thing is inside this user object, we have another object size. We have another object size. So how do we clone it? That's an interesting question because it's an interesting interview question. This is an interview question. So one very important thing we need to understand is um, I'll say let clone is equal to, we have this object dot assign where first I'll mention this is an empty object where I want to copy user, where I want to copy user. Now one very important thing we need to understand is once you do that thing, once you do this one very important thing, let's say user dot size is actually triple equal to clone dot size, clone dot size, because we have to be very careful when you are dealing with these things. Okay, this is dot, my bad, this is comma. Right. Now, if you can clearly observe that whatever this copying for both the clone and for the user are now being actually acted as same. Actually acted as same. Now let's try to do this one thing. This is giving me true, telling me or true, telling me this one very important thing that both are same objects. This whatever this size is present inside user object and whatever size is present inside this clone are actually same. Are actually same. One thing. Let's try to make changes. User dot size dot width. Initially, it should be something value as 90. Now let's change its value as 100. Now once you made this value as 100 change, if I console dot log and check whether clone dot size width is also changed. Clone dot size dot width. If you can clearly see 100, this value, this output is also 100. It should not be the case because let me write the reason. In the above code, we have cloned the elements, we have cloned the objects, but the nested objects are still referring to to same object, which is this one very important thing, which is when we are cloning or duplicating, when we are cloning or duplicating, both user and clone should be different, different, or both should be independent, independent to each. But in the above example, but in the above example that we are actually seeing this thing, but in the above example that we are actually seeing, if we change width property of user object, then the same change is also visible in the clone object, in the clone object, in the clone object too, which should not be the case. So here we have changed From the user, we went to size property, and in that we have changed the width property. Because once we are doing this clone, we are doing this entire cloning part, we assume that this user is a separate independent object, this clone is a separate independent object. But what exactly we found to know is the nested objects, this size, this one single size object, where for user and for this clone are referring to same object, are referring to same object. That's why whenever you make changes using user, width has been changed, and that same change is also reflected when I try to add access the same property using clone, same property using actually clone. So here we have to be very careful. Here it should not be the case, here it should not be the case. So what should be done is, let me write it. It should is, I'll say let user is equal to name as Nathan, and I'll say size is equal to gight height as some 80 and width as 90. Now what we have to do is we have to do one thing, one very important thing known as a structured clone. Structured clone. Structured clone. We have to do this given particular thing known as a structured clone. So this call or this structured call clones the object with all nested properties. With all nested properties. So here we have this thing. Let's try to implement it. I'll say let clone is equal to structured clone, and I'll mention users. That's it. I'll mention user. I'll say console.log clone.size triple equal to um user.size. Run the code. You'll see this value as false. You'll see this value as false. Because here, whatever things that are present, this size nested object present in clone object, this size nested object present in user object are both different. That's why you got result as false. But here in the above example, when we try to compare them, we got the value as true, which is nothing but here this size or the nested object in both user and clone are actually referring to the same object, are actually referring to the same object altogether. So this is how we have to focus upon this respective thing known as a clone. Now another important thing I just want to mention is sorry, that garbage collection, we can say that a memory management thing is actually in JavaScript is performed automatically, and it's completely invisible to us. So we create a lot of things. We create primitive data types, we create functions, we create objects, and all such kind of a things. All of that thing will take some kind of a memory. So at a given point of time, if your JavaScript engine doesn't feel that it is actually a required element, then it actually removes it. So JavaScript engine follows this one principle known as reachability. Let me write it like this, because going depth into this garbage collection might not be very useful for you. But whenever we take up this advanced JavaScript part, we understand how do we implement advanced JavaScript things. That's a completely different session altogether. Here we are actually in this entire sessions, we are actually focusing on teaching this entire JavaScript part, but it's not the other way around. So sorry. So what we can do is what we can do is there is this thing known as reachability. So the main concept of memory management in JavaScript is reachability. So to simply put it, which is nothing but reachable values are those that are accessible or usable somehow, which is nothing but whenever we have created 10 values, out of 10 values, we are reusing or we are using only 5 to 6 values, 5 to 6 variables. Then those 5 to 6 variables are actually guaranteed to be stored inside memory, to be stored inside memory. Any other value is considered as reachable, then it is actually stored inside the memory. Let's say if you created a global variable, or if you created an object which is in a global variable, then that global variable has reachability, where that global variable can be accessed in any other functions. So these will be stored in a separate thing. This will be stored inside a separate thing. And there is also a background process in JavaScript engine that is actually called as garbage collector. Actually, it monitors all the objects and removes those become unreachable. That's a completely complicated process, that how it actually works and how doesn't it actually works altogether. So to understand this given particular thing, it's completely a bit typical to understand the internal algorithm that is present in, because garbage collectors works in a different format. It matches, sees the visits, it actually checks how many number of visits as a Markov's references, and it visits the marked objects and marks their references. It is completely a chaotic algorithm altogether, but it is very interesting algorithm altogether. But at some point of time, when we are dealing with the advanced part of JavaScript, we'll try to understand how does this entire internal algorithm actually works in a given particular thing. But to be more precise, at this given point of time, we can end our session that this garbage collection will be only following this one thing known as a reachability. Apart from that, there is nothing much we can learn at this given particular point of time. Even if you go and learn, it will be a bit tough to manage all these things together. So that's it for this session. We'll meet in another session. Thank you all.